Hello everyone, welcome to week 2 of Gamma lessons. I hope everyone can hear me and I hope that I'm clear this week. Uh, just respond to me on the live chat if I'm audible and if my live session is working fine. Okay, so in the previous week we started with the responsive facades as a target, and I'm just going to take that topic a bit more ahead, and I'm just going to complete the research that we had taken earlier with the previous week session. I'm just going to run through the document that I have shown in the previous week, and I'm just gonna recap what we have done. We had done earlier, as I was not clear last week. So I would just very quickly go through all a presentation that I had given earlier, and also I'm just gonna show the video that I had shown earlier again once. So that you guys who are new to Gamma lessons can definitely get a gist of what we have been working through. In the week 2 of responsive facades, we would be learning how facades could be treated as a media screen. As the research that we have taken highlighted some elements of how a facade could be used as a way of marketing. So that's what we would be doing today. Just to run through G.A.M.A again this week. It's an education institute for designers basically, and we are interested in dealing with technology and advanced fabrication methods. As the name suggests, G.A.M.A stands for Geometry, Algorithm, Modeling and Architecture, and we aim to explore and express works within these segments to form a relationship between design and emerging technology. Some of my previous works include some digital workshop as well as this fabrication workshop, some being robotic fabrication, and these are some of the photos of earlier done workshops. First few could be the digital workshop which was done in December 2018. These are all the images of documented images of the summer school that we did at Balwant School of Architecture, Mumbai, and the topic was to explore curved crease folding at various scales in architecture. And this again was a session or a workshop that was done in collaboration with D3 Labs and IAT Barcelona, where we explored incremental sheet forming to form a pavilion. So for this week's G.A.M.A lesson, we would be our objective is to understand facade as a media screen. Previously and the research that we have taken for showcasing this is something that we were doing earlier this week. In fact, in the past session that we did, hybrid responsive facade by Idea Labs, and I will just run through the video that I had played earlier so that you get more clarity about what these facades are. So in the previous session we divided this problem into basically three smaller problems. First is how do we make the geometry, second is how do we operate these facades, and third is how does it respond to a third body, or say an attractor point or sun. So for that matter we use these following steps, where we started with the hexagonal grid. We scaled each cells in say y in y direction of the plane to get the front face of the geometry. We extruded those geometry to a certain extent, and then we lofted the edges to form the geometry. Secondly, for operations it was quite simple, that all the cells were rotating at some angle to respond or to create a responsive facade as a whole in its z-axis. So that was the operation, which was quite simple to understand, and to make it responsive we used the attractor point logic, where we check the distance from each cell, each center of the cell to the third or a point which is an attractor point, and then we remapped those distances within 0 to 360 or 180 degree to get the rotation angles. So that's something that we did previously. I'm just going to run through the previous week's step so that you get a bit more clarity about how we try to figure this problem out, which was like the first part of making this facade. Today we would be doing obviously the media part, how we could take a facade and we could convert that facade into a media screen, as we saw in the video. So in the previous weeks we started with a hexagonal cell, hexagonal grid to just form the base of this facade. We deconstructed those cells to get individual cells and individual faces. We used an indirect method of getting the center by taking the area of each cell, and then eventually scaling those cells to get the offset. So to get the offset we just scale the whole we scale each and every cell with respect to its center to get with a fraction of 0.9 to get the offset of those hexagonal cells. And then next step we did was we deconstructed those planes, we gave it an amplitude, and we moved those geometries in say its z direction, and then eventually we scaled it to get the front face. So at this point we had a front face and we had these rear faces. So if I could just, I'm just going to reduce the number of cells so that it's a bit easier for us to see. So I'm just going to reduce the number of cells now. Okay, so as you see here, so this was our initial geometry, and then we extruded those geometries and we scaled them to get the faces. So we could get some things like this. Now to construct the whole geometry, we need to construct the sides of these geometries. So for making the sides, we just took the curves, we took these curves of the geometries, both the geometries, the front and the rear geometries, and then we just lofted those geometries. So you could form these kind of cell, the side faces of these cells, and then eventually just joining the whole geometry together to form each to get individual cell units. So that was the making part. That was how we made these geometries. To make it more responsive, we introduced a point which was an attractor point that we just named it. So we introduced a point here, and then we check the distance from the center of these points. So I'm just going to put this. So we check the distance between these points, which is which are the center of each geometry. So we check the distance between each point, each of these points to the attractor point that we have taken, and based on that we remapped the values that we got. So these were the initial distance that we acquired. So this is the distance between each of the center of these cells to the attractor point. So if you see this diagram here, so we are doing something like this where we had an attractor point, and then we had the center of each cell, and we are just checking the distance of each center point to the attractor point. After acquiring those distances, which are these, we are remapping each of these values between 0 to 180 degrees. So when you see the remap values, I could have these two lists. So basically we would be using these the second list, which is the list that you see in green, as the list for creating or to give transformation to each of these geometries. So the geometries would rotate with these angles. So you could see some things you might have to wait for some time. So you can see some things like this. So if I change my attractor point location, I could see my facade being responding to my facade responding to that attractor point. If I see this facade with if I gonna show you a reference. So it's taking time to read and make the so just so I have something like this as a reference, and so if you see my attractor point, which is here, if I try to move this attractor point anywhere, my facade responds to this attractor point. So that's the responsive part of this facade. If I take any geometry, or let's say so for this matter, if I take any other geometry and if you use a similar kind of logic of attractor points, you should be able to get a responsive facade in a similar way. For this case, I have taken this particular example, which I found and I feel it's quite interesting to look at. So that's why I have taken this as an example. But you can definitely try different kind of facade systems, starting from a grid and then eventually forming your own geometries, and then making it responsive. So that was previous week's session, which was not exactly clear, but obviously I hope that we had a good recap. And just to start, today's session would be a bit more short, I would say. This event, G.A.M.A lessons, it's more like a progressive event where we are focusing on smaller tutorials and then eventually building the idea of like making smaller functions form a bigger script. So that's how we are trying to progress in this event. We won't be doing very big scripts in each session, but there might be some sessions where we might do some bigger scripts, which could be much more intense. But for these starting seminars or starting sessions, I would be doing shorter scripts, and those would be more progressive scripts. So that the previous week was the part 1 of hybrid responsive facade, which was how it would respond to an attractor body. And this week we would be doing how it could turn into a media stream. So the logic is very simple, and the steps are quite simple. In fact, I would like to show this example on a surface first, and then eventually we would move from surface to a facade. So I'm just gonna hide everything on my screen, and I'm just gonna start fresh with a surface so that I could explain the script better. So I hope that the previous week session is clear for everyone, and if there are any doubts, you can definitely write in the live chat, and I could have a look and maybe get it cleared. Okay, so I'm just gonna start with a rectangle here to let's start with just a basic surface to explain it better. I'm just gonna make a very quick surface in Rhino. Just gonna reference it in Grasshopper. So you can take in surface, right click, select one surface, and that's your surface. So what we would like to do is we have these set of images that I have collected from the internet, and those images would we aim to show those images on the facade. So let's say I pick this image. So these are the images that I have collected from the internet, and I hope to just showcase some of them as a way to express these geometries on my surface. So for that matter, what I would be doing is I would first divide this surface to get the points on the surface. So for this matter, the default values are 10. So I'm just going to change it, and I'm just going to put my own default value. So for this matter, I'm just taking 2 U and V value, 10 each. I could increase, and I could get the number, higher number for this matter. And so these are all my points. And this is the surface. So the way it works is, so there are just few steps that we need to follow to get an image sampled on our surface. Our surface has to be reparameterized, which means it has to be between 0 to 1. So the U values and the V values has to be in the domain range of 0 to 1. I would tell you why it has to be between 0 to 1. Second is we need to divide the surface to get all the points on the surface. Once we have those points, we can use those points to get the distance between, or say, get the intensity or the depth of the image from the surface, and those depth values or intensity values can then be used to create transformations. So I'm just gonna put in surface closest points. So I have this surface which has to be reparameterized. I have points. I should get my UV points, which are the points on the surface, and those points then goes into my image sampler, which contains the image. So in this case, I'm just going to pick this image. So you can, so the reason I was saying your surface has to be reparameterized is because it has to be between this domain range of 0 to 1, which is also the domain range of this image, which is quite important because if the domain range matches, only then we could so you could say that the point that we have used for divisions are we would be using a similar points to find the intensity at those points of this image, and those values would then be used for creating some kind of transformation or creating any kind of geometry. So, and I'm just going to select my channeling to grayscale, color brightness, sorry. So once I have this, I could see my values in this way. So right now everything is 1 1 somewhere. So what I could do is I could just put circle CNR. So the reason what CNR means is it asks for a center, normal, and a radius. So in this case, let's give a radius of so I could see that when I connect these points, my surface points, I have the circle values. What I want right now is I just want to have this image sampled on this surface. So what I could do is I could just scale these, scale the circles on the circles, and I could use maybe these points. So these evaluated points become centers and I need to evaluate the surface at these points, and these points then go into making my these points will eventually give me the normals. This will be my center, and I'm just going to give a multiplication value. You can see that I have something which looks like my image. but as like the way we have divided this surface, it's not exactly it's kind of a flip of this geometry that we have taken here. What we can maybe reverse. So I'm getting an error because there are some values which are equivalent to 0 because it's inexactly. So in this case, it checks the brightness of this image and eventually projects some values. So there are a lot of values which are equivalent to 0, and it scaling factor. A scaling factor which is 0 is not something that Grasshopper can compute well, so that's the reason that we are getting an error. But we could see the result anyway. So that's something that that's a small example of image sampling on a surface. But how do we use this logic to create a facade, a media facade, for this matter, for this particular example? So if I recollect some things from our previous done sessions, these are all the geometries that we created, that being the center of these geometries. So I'm just going to take this and paste it again so I can start new from here. Okay, so as I told you earlier that I like to move more in groups, so I just first sketch what are the steps to create to form the object, that meet the objective, and then eventually work towards it. So as we had listed down some of the steps in the presentation, that we need to divide these surfaces. Then we need to find a closest point. Remap those values to get the rotation angles. And then transform. So in this case, transformation is equal to rotation. Okay, so these are the 4 steps that we need to follow. We have these geometries, we have these volumes, and I have just taken the data of the U's and V's, or the extent of the cell in X direction, the extent of cell in Y direction. Those are the 2 data that I have taken here. I will tell you the reason why. So because we need to first make or create a surface from where we can say find the closest point of any image of the images of the points on the image. So for that matter, I have taken these values. So what I would do first is I would first like to create a surface from points. So I have this command called surface from points, and I'm just going to use all my center values, and this being my U value. So that's something that is a surface that I would eventually get. I'm just going to close this. Okay, so that's my first step. I'm just going to get so in this case I don't need to divide the surface. The reason I was dividing the surface was to get the points, but I already have these points, and I'm just gonna check these points. Surface closest point, so I could get the UV parameter, UV point parameter. So in this case I'm just going to use the surface and these points to get the UV parameter, and that would go in my image sampler. So in this case I'm just going to take any random video, any random image. Let's say I take in say this one. Okay, I'm just gonna put the channel as color brightness so that it checks the depth of the image and eventually give us the value. So I'm just gonna put in these points. So if you wanna, so these are the points on the surface, and these are all the values that we would be getting here. So I can see that I can get some points which are within the range of 0 to 1 because I reparameterized the surface. So once I have these values can then be used for remapping and get the rotation angles as we designed. So as I had shown earlier, there are some commands which more or less goes together. So whenever we use a remap component, we need to give in a target domain, which is domain that we would be setting here. So the domain eventually becomes our range of angles. So we would go from say 0 to 180 degrees. So we could say we are going from 0 to 180, 45 to 90 degrees. So we could get these new remap values here. So you can see that I have got, if I compare both the data, both the lists, I could see that previously it was between the range, domain range of 0 to 1, and now it is between say 45 to 90 degrees. So I have just remapped those values to get me the rotational angles. So I'm just going to make some very quick groups here. So I'm just going to say that points on surface, we have this as closest point, dot UV2, and then these are our remapped values. those things goes in. Okay, so that's the G.A.M.A values. So now we just have one thing to do, that we need to transform these geometries. So for this matter, I'm just going to rotate these geometries. So as you see that I have rotated these geometries, and I have just used my planes as these points, or these points are the center points. So those will be my points. So let's take these geometries which we need to rotate. Okay. So for now it's rotating all these geometries which we don't want. So also we will be changing the degrees, and we need to mention the planes. So in this case my planes would be my center of each cell. So once I do that, I could see my, if I just close this, I could see that there is some rotation that has happened to my cells. I'm just going to use these G.A.M.A values as my degrees, and you would see that we would have some things like this. So I could just change this from 120 and I would suggest that you start, you could definitely try it with a smaller number of cell units, because it takes time to compute, and sometimes it could just keep you waiting for a very longer time than expected. So yeah, so that's and if I just show you the context, so that's my so I can change these image. I can just put in any other image, and I can have something like this running. So eventually creating another function to this facade, which could turn as which could respond differently, as well as it could be used for creating advertisements or media on the screen. So that's one way how you could achieve it. As we were seeing in this video, so they were using these images to showcase on the facade. So you can imagine that they were using a similar logic where they were using these images and sampling them up to create rotation or transformation for these single cell units. So yes, that's more or less that we will be doing in today's session, and that completes the first objective of or first exploration basically of this research. We learned to first create a responsive facade, and then also we learned how to make this facade more like a media screen and not or we can say that we learn how to make this facade respond differently to different parameters. So um, that's something that I found very interesting in this research, and these 2 weeks would more or less close the first reference that we have taken of Idea Labs, which is the hybrid responsive facades. So thank you very much for attending today's session. I'll be seeing you next week with another objective. We would reveal the objective anytime during next week, and we hope to see you again. Thank you. If there are any doubts, please you can comment on in the live chat session, and I could just, or maybe if you have any problems with the script, you can definitely email me. And just to brief you all on our upcoming event, which is going to happen in Pune, we have this session called Scalar, and we would be doing the level 1, we would be doing the level 1 workshop on Rhino and Grasshopper. It's going to be on 30th of November till 8th of December. So we have 2 weekends where we will be exploring about and we will be more or less doing all the exercises that we will be covering in this month. So people who would be joining in for the workshop could treat these weekend webinars as a kind of warm-up sessions for the main event, you can say. And you could definitely kind of pre-learn some things to help you understand the software as well as the logic of creating something much more better. So one very important part of this workshop is that we would be working on live project, and we are collaborating with MetaArch Pune, who are an architectural firm and based in Pune, and they are working on various large-scale projects. So we will be taking up some of the projects which are under construction, and we will be creating some of the elements of those projects using Grasshopper and Rhino, and those output of the workshop would be presented or would be eventually sent for further approval. So if we got accepted, if the designs get accepted, we could get a chance to build or fabricate those elements. So that's a good part about this workshop, and I would definitely recommend people who would be interested in learning Grasshopper and Rhino to attend this workshop and see a live demonstration for using parametric tools in architecture. Also, I'm getting a lot of requests from people around to avail a webinar service for this workshop. So we could definitely work this thing out, and I would just let you guys know if the webinar would be available once I discuss with my team, and we could definitely get back to you through our digital platform. Talking about the digital platform, there is also this technology that I would like to make you all aware about. It's called Townhouse 2.0 or TH 2.0 in short. So it's a technology on co-living and co-working, which is gonna hit the market soon, and it's something that I would definitely recommend a lot of people to check it out, because we are creating some algorithms which is gonna make co-living and co-working simpler and much more efficient in cities. So this is something that I would like you all to have a look, and we would be keep making our Instagram page live next week. So definitely have a look at this. You can read more about TH 2.0 on our link, on this link, www.th2-0.com, and you can know more about how this technology works and what is so different about this technology that's going to make the co-living and co-working simpler. Also, you can follow me and my page on Instagram, and just to address our media partners and collaborators, our guys who has been making us famous for a lot of reasons. So big thanks to them. And thank you very much for attending today's session. I would see you all next week. We would keep you updated with next week's objective, and we hope to see you every weekend. Thanks.